Okay, so welcome back, and now in this video we're going to look at more complicated looking sequences. For example, this one here. Okay, so this is more complicated than any of the other sequences we've looked at thus far. So determining whether this is going to converge or not is actually simpler than you might think, because we can actually use to find whether this converges or not by comparing it with these sequences separately. And so we can see that based on our previous discussion that this is going to converge to 0, this sequence converges to 0, and so the sum of these two is going to converge to 0. Okay, so we're going to use some other properties because it makes sense that this would be true, because if we can represent these as functions, right? So if we can use functions to compare these two, f of x, so if we use f of 2/3, oops, let me do this. So f of x equals 2/3 to the x, and g of x if we can compare those functions, right? So again, just like the limit laws, so remember the limit laws. If we can compare sums, algebraic expressions of functions, right? So if we can take something like this, if we could take like h of x equal to 2/3 x plus 1/4 to the x power, and we can compare this to other functions, and we can use the limit laws, right? Because limit laws, the limit of the sum is the sum of the limits. So it makes sense that if we can do this for functions, that we can do analogous things with sequences. And so that's what we're going to talk about in the next video. We're going to introduce the limit laws for sequences. Take care.